Now, talking about the periodic table. Now, talk about we're going to discuss on the periodic law. But before we talk about the periodic law, we're going to see talk on the periodic table itself. The periodic table itself. So after that, we're going to discuss on the periodic law. After the periodic law, we'll discuss on the blocks. After the block, talk about the families of elements in the periodic table. After that, we're going to talk about the atomic radius, talk about the ionic radius, talk about electron affinity, talk about ionization energy. So these are the subject matter we're going to discuss on in the course of this particular topic. Now, the periodic table. So if you look at my diagram here, I have the sketch of my periodic table. Now, if you look carefully, I have the group. I have the group which I circle. This is the group, and the group is from group 1, group 2, down to group 18. Some textbook will say, some textbook will tell you we have group 1 to group 8. That is, okay, now let me do something here. We have 1, we have group 2, we have the group 3, group 4, group 5, group 6, group 7. Here we have the group 8. So that is the group 1 to group 8. And here we have the transition element, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now adding this 10, this 10 group to the 8th group, it gives us this 18 that we have in this place. Now, in the period, we have period 1. Period 1 goes this way, the period 1, period 2, period 3, period 4, period 5, period 6, period 7. Now in the group 1, we have the group 1 down here, group 2 down, and here we have the group 3, group 4, group 5, group 6, group 7, and the group 8 in the periodic table. So the periodic table is divided into group and period. We have the group 1 to group 8, and also known as the group 1 to group 18. We have the period 1 to period 7. Now on my periodic table, we have the alkaline metals, we have the alkaline earth metal, we have the transition metal, we have other metals, we have the metalloid, we have other non-metal, we have the halogen, we also have the noble gas. So now it has been made easy for us with the color differentiation. Now if you look at this particular color here, which is the alkaline metals, so now telling us all the group 1 apart from or except hydrogen, the group 1 here, they are all alkaline metals. Now we have the alkaline earth metals, which is states, which is the group 2. Falls on the group 2. We have the alkaline earth metals. So saying that directly we have this group 1 to be our alkaline what? Metal. They are known as the alkaline metal, while the group 2 are the alkaline what? the alkali, earth metal, the alkali earth metal, alkaline earth metal. Good. We have the alkaline earth metal. So before we go into all this, we are talking about this periodic table was brought forward, was looked into by many scientists. So the periodic table we are enjoying today in our various schools, in our various places, were there was based on the efforts of many scientists, or the early scientists like Lavoisier in 1787. We have scientists like Lavoisier. We have scientists like Lothar Mayer in 1865, and other scientists like Newland. Also, these are the earlier scientists that put effort to the periodic table. But it was not until in 1869, it was not until in 1869 that a scientist, a Russian scientist, a Russian scientist, Russian scientist, a Russian scientist, or a Russian chemist, a Russian chemist or a Russian scientist in what? 1869. So it was 1869, a Russian scientist known as Mendeleev, known as Mendeleev, known as Dmitry Mendeleev, known as Dmitry Mendeleev, known as Dmitry Mendeleev, discovered that when he arranged the elements in order of increasing atomic weight, similar chemical properties occur over and over. When he arranged the elements in increasing atomic weight, similar properties occur. Similar properties occur over, and similar chemical properties occur over and over at regular interval. So now with that, he puts forward what we call a law known as the periodic law. The periodic law states that the the physical and the chemical properties of an element varied periodically with respect to their relative atomic mass. Now we can use it, we can also say with respect to their relative atomic weights. That's it. With respect to their relative atomic weight. So that is the periodic law that Mendeleev put forward. So now this periodic law and the arrangement of these elements in order of increasing relative atomic weight or mass brought about many gaps on the periodic table. Brought about what do I call it? Many gaps on the periodic table. That some elements were not seen, elements were missing, that some elements are not there, that supposed to be in a particular group are not there. Now, these elements that were not there, Mendeleev has, I come again, Mendeleev has predict their chemical properties. Mendeleev has predict their chemical properties. Examples of this missing element we have gallium. Example of this missing element, we have gallium, and other elements such as germanium. We have germanium, we have scandium, and so on and so forth. We have germanium, and what again do I call it? We have germanium and what? Scandium, etc. There are some elements, some of these elements that were missing in Mendeleev's periodic table. But remember, I told you that he has already predicted the properties of some of these missing elements that was found on the periodic table, Mendeleev's periodic table. Now, with discovering of the electronic configurations of atom by the use of atomic mass, brought about the modern periodic table. Now, the modern periodic table brought about the modern periodic table. So the modern periodic law brought about the modern periodic table that every one of us are enjoying today. So let's take the modern periodic law. Is the basic the modern periodic law is the basic assumption behind the periodic table is the periodic table rather sorry the periodic table okay, let me have it this way. The periodic table is the basic assumption behind the modern periodic law. The basic assumption behind the modern periodic law or periodic table, which states that the properties, which is what? The physical and chemical properties of an element, are the periodic function of their atomic number. The periodic function of their atomic number. The periodic function of their atomic number, which led to the modern periodic table. Now, secondly, we are going to the next subject title, which subtopic, which is what? The block of elements. And let's go back to the periodic table. Now, if you look at the periodic table here, I told you earlier on, we have the group, which is this, the group, we have the period. So now from this part, from here down, from hydrogen down, here are the group 1. Now these are the group 1, and we have from beryllium down to this part here are the group 2 of the periodic table. They are the group 2 of the periodic. Okay, talking about the periodic tables. Now we're talking about the elements, the block of elements. Now, if you look at my periodic table I have here, I've explained some things earlier on this, which I'm going to lay more emphasis on. This is the block of element. Now we have based on the electronic configuration from the position of the various elements on the periodic table and the electron arrangement or the configuration seems to stand out. Elements that have one electron in their last s orbit. Element that has one. That is, I'm going to explain this in briefly, or I'm going to explain it extensively. Now, if you look at the group 1, These are the group 1 elements. Now they are called the group 1 element because what? They have one valence electron in their outermost shell. They have one valence electron in their outermost shell. Now talking about one electron in their outermost shell, I'm going to do something here. So please pay attention. One valence electron in their outermost shell. Now talking about the group 1, let's take one element in group 1 as an example. Let's take lithium. Now lithium, the atomic number of lithium, okay, let me have it here. Atomic number of lithium is what? 3. Is 3. So therefore I have 1s2, 2s1. Now if you look at this configuration very well, now the last electron falls on the s orbit. Falls on the s orbit. Look at it here. Falls on the s orbit. So the group 1 are called the s block elements. Not only the group 1 are called the s block element. Let's say the group 2. The group 2, let's take example like beryllium. Beryllium has the atomic number. Beryllium has the atomic number 4. So I have 1s2, 2s2. So it falls on the s orbit. Now the difference between the group 1 and the group 2 is this. Now for the group 1, they have one valence electron. They have one valence electron in their last orbits. The group 2 has what? 2 valence electron in the last orbit. So saying the group 1 and the group 2 are known as the s block. The group 1 and the group 2 are known as the s block. Now this is the block we are talking about. Remember we are talking about sorry. Alright, sorry for the break in transmission. We're talking about the block of elements. Now I've earlier explained one thing here. I said talking about the group 1 and the group 2 using lithium and beryllium. So we come here, we said lithium having atomic number of 3, here. We say we have 1s2, 2s1. So 1 electron in its outermost shell, but still fall on the s orbital. Falls on the s orbital. The same thing with the group 2, falls on the s orbital. So that is why the group 1 and the group 2 are known as the s block. Now let's come to the next block. The next block we're talking about the p block. Now the p block are the group 3 down to group 7 are known as the p block. Then are known as the p block. Now you want to ask question, why are they known as the p block? Now let's take an example. Let's do a little work the way we did to the group 1 and the group 2. Now let's take one element in the group. Okay, I'll just pick one element in the group 3 down to the group 7. Now take a carbon, taking oxygen, nitrogen, oxygen, and fluorine. Let's take boron as one element among the one element each in this group. Now boron has the atomic number 5. Boron has atomic number 5. So we have 1s2, 2s2, we have 2p1. So it falls on the p orbit. Falls on the p orbit or orbital. Falls on the p orbital. That's why we said the group 3. That's what we said from the group 3 down to group 7 at the p block. Let's take carbon. Now let's say carbon now. Carbon atomic number 6. Atomic number 6. I have 1s2, 2s2, 2p2. So still on the p orbital. P orbital. Same thing goes to nitrogen. Same thing goes to nitrogen. We have nitrogen atomic number 7. Atomic number 7. Alright, students, we have talked about the family. You don't just forget about the diagram. We have the periodic table is very simple. If we put the mind there, it's very simple. Now, as I was saying concerning the family, concerning the block, we talked about the S block being the group 1 and the group 2 elements. So we pick lithium as the group 1 and we pick beryllium as the group 2 element. So students, we're going to see the p block element. Now for the p block element, remember I told you the p block element comprises of the group 3 down to the group 7, which we have we're picking one element each of the p block. Now the reason why we are saying, or we are calling them the S block family, or we are calling them the p block element, and so on and so forth, is because their last electron is found on the S block. Their last electron is found on the p block. Now look at example now. The one I have here for lithium, I have 1s2, 2s1, 2s1. Now the last electron, which is 1, falls on the S orbit. Falls on the S orbit. The same thing goes to beryllium here. Beryllium, the last electron, which is 2, falls on the S orbit. It falls on the S orbit. Now, each of this group, the group 1 and the group 2, they have the last electron in their S orbit. They have the last electron falls on their S orbit. That's why they are called the S block element. Called the S block element. So students, you see that it's very easy to identify the block of element. Now let's go to the p block element. The reason why we say that the group 3 down to the group 7 are called the p block element is because their last valence electron, is found on the p orbit. Now for example, we have here, we take boron having the mass atomic number 5. So we have the 1s2, we have the 2s2, we have the 2p1. So the last electron, which is 1, is found in the p orbit. Is found in the p orbit. Same thing goes to carbon. Yeah, we have carbon atomic number carbon 6. We have 1s2, we have the 2s2, we have the 2p2, still on the p orbit. Now let's take nitrogen as the next one. The next one as nitrogen. So nitrogen, we have atomic number 7. Atomic number 7. So now we have 1s2, 2s2, 2p what? 2p3. So still on the p orbit. The p orbits or orbital still falls on the p orbital. So it still falls on the p orbital. The same thing goes to oxygen and fluorine. That's why the group 3 down to the group 7 elements are known as the p block. Are known as the p block. Now the group 8 elements, they are known as the noble gases. They are known as the noble gases, and they are noble. They don't have to collect elements from any other person or any other group. So we have seen the S block element, and what again we have seen, students, we've seen the P block element. Now let's go to the D block element, which is the next block element. The next block element. Remember when we talked about the electronic configuration, we said something. Look here. We said we have the S, we have the S, we have the P, we have the D, and we have the F. We told you earlier, I told you earlier on that the S block must carry maximum number of 2 electrons, the P block must carry maximum number of 6 electrons, the D 10, and the F 14 respectively. 14 electron respectively. So let's go to the next one, which is the d orbital. Now from this between the group 2 and the group 3, we have elements that are found there. These are the elements that are found between the group 3 and the group 2 and the group 3. They are known as the 3D